So welcome back to another video, guys. In today's video we're once again going to be attempting to solve a question paper in real time. This is going to be question number 1 of 9618. The year is 2021 and the variant is 41. So for this paper, just like the paper in October November 2021, there is basically one variant, which is one unique variant instead of 41, 42 and 43. So we are going to be solving 41, but it's going to be the solution of all the variants of May June 2021. Alright, so let's start with question number 1. Now before starting off, I'd like to tell you that this is like the fourth or the fifth video of our question paper solving series, and we started with October November 2021. Yeah, we did not go chronologically, but if you guys want to see those videos, it will be linked in the description. And we have completed all the three questions, question 1, 2 and 3 of October November 2021, right? Okay, so starting off with this question, it says an unordered linked list uses a 1D array to store the data. Alright, so it uses a 1D array. Each item in the linked list is of a record type node and a field data and a field next. So normally when we studied linked list, what did we teach linked list using? I taught you guys linked list as part of OOP, right? Where we created node objects and each of those objects had a data attribute and a next node attribute. So here the words are a bit changed around, but it's basically the same idea. The current contents of the linked list are start pointer 0 and empty list 5. So this table is given. So first thing first, we will try to analyze this table. Um, okay, before moving on to that, let's see what question number S is. The following is pseudocode for the record type node, blah blah, write program code to declare the record type node. So basically, record type is essentially, in this case in Python, we're basically going to create a class of node. So let's do it. We're going to create class node and a very basic constructor which will have the init data equals to data. We're going to pass the data from here. We're going to pass next node from here. Self dot, we can just keep it as next, or we can just make it next node equals to next. Right, so done. We have created a node class. Let's see if it's working right. So n1 equals to node. We can just create 30 comma none, and we will try to print n1 dot data and print n. Sorry about that, guys. What just happened? Okay, we're good. Print is going to be n1 dot next node. Right, let's try to run this. We get 30 and none, and our node class has been created. Great. Next, we move on. We have write program code for the main program. Declare a 1D array of type node with identifier linked list and initialize it with the data as shown on table 2. So we basically need to create each of these nodes. Now, first of all, we need to create a 1D array. The name of my 1D array is going to be linked list. Alright, so let's do it. We're going to create a linked. Let's get rid of this part. Linked list. Is there any separation? Okay, there's a capitalization. Linked list equals to. Let's just start with empty brackets. So we just initialize the list, and then we need to create it of node data type. So what we'll do is linked list dot append, and I will basically create the nodes and just append them. So I will create the nodes using what? Let's keep this side by side. Okay, so for my first one, the data is 1 and the next node is also 1. Great. And we'll do this for all the 10 elements. So the next value is gonna be 5 and 4. Next we got 6, 7. Then we have 7 minus 1. Then we have 2, 2, 0, 6, 8, 0, 56, 3. We're gonna need a couple more. This is gonna be minus 1, 0, and this is gonna be 0 and 9. Alright, so now remember, if we try to do this, that print linked list, we will basically not be able to see each and every element or each and every dot next values. Instead, we will only see the address of each and every object that got created. So always remember this. You see, you get over here, this is a node object that got created. A node object got created. So basically, the data type of this linked list, or basically this array or list, whatever you call it in Python, is node right now. Alright, so we have done the first two parts. Then it says the procedure output nodes take the array and start pointer as parameters. The procedure outputs the data from the linked list by following the next node value. So what do we have to do over here? You see, this is okay. So let me do the simulation real quick. Let's take it from here. Go to our mirror. Paste it. Okay, so how will the data go? The data, first of all, I'll start at index 0 because this is my start pointer. Remember? So I come over here and I get a data of 1. And then this is pointing to what? This is pointing to index 1, which has a value of what? 5. So if I was to create it in the visual that we are more familiar with, this is what the visual looks like. 1, this is pointing to 5. Alright? And then you take one more step. What will it point to? It says go to 4. So from here, I need to go to 4. So here will be 2. Then where will we go? You go to 2. So I go here. So next we move to 6. And then we go to 7. So 7 is what? Okay, let's make this clean. Looks very messy. So we go from here to 4. From here we go to 2. And then from here we launch to number 7. So from 6 we go to 56. And then from here we go back to 3. So from 56 we go to 7, and then minus 1. Do we have an index equals to minus 1? No, right? Basically in Python you do, but in this case minus 1 is basically saying that this is pointing to none. Alright, there's nobody after 7. That is your linked list. So we have this linked list, but there are other values over here, right? The question is, what are these values and how are they significant? So we have these 4 values pending. So remember, we had one more variable over here. The variable was empty list, and it said that the empty list value is 5. So see, where do we have our first unused element in my index according to the index over here? This is my first unused element, right? Everyone else is used. This is used, this has been used, this has been used, this has been used, and this has been used. So all the data which has 0 in it, all right, everywhere where we see a 0 data, those are my unused element. And my first unused element is at index equals to 5. Hence, my free node, sorry, not free node, what was the name of the variable? Empty list will basically refer to that where can I add a new node if I ever have to add a new node. All right. So that is the purpose of empty list. So you go from here and then it says that you need to go to 6, and then from 6 it says you need to go to 8, and from 8 it says you need to go to 9, and from 9 it basically ends, right? Once again, after 9 you can't really have anyone else. All right. So that is how we basically have one filled list, and we have one empty list, and we will basically take one by one element and basically make this list bigger. So if I were to show it as a visual, this is what we also have. We have a 0, this is at index 5, this is another 0, this is pointing to index 6, this is another 0, this is pointing to index 8, right? Yeah. And then we have another 0, which is the last 0. This is pointing to index 9. So suppose I now have to add the value of 73. I want to add this to my linked list at the end of my linked list. What can I do? I basically need to take one of these and add it at the end over here. All right. And then accordingly, my empty list will start from 6 and so on so forth. So এই পার্টটা হচ্ছে একটু বুঝার গাইজ যে এমটি লিস্ট কিভাবে কাজ করে। once you figure out যে what's the purpose of empty list, and start pointer is very intuitive, but once you figure out what's the purpose being served by empty list, the rest of the question is a walk in the park. So now let's come back to the question. It says the procedure output nodes take array and start pointer as parameters. The procedure outputs the data from the linked list by following the next node values. All right, so this is a very simple one. What do we need to do? Let's write def output node. It will take the array and start parameter pointer as parameter. What was the name of my array? Linked list. Linked list, and we have start pointer. All right. Now what do we have to do? We start from start pointer and we basically continue until and unless we hit a -1. The procedure output nodes take the arrays. The procedure outputs the data from the linked list by following the next node value. All right, sounds good. While okay, we can basically go for a while true and then adjust the condition later. Print. So we need to start at the start pointer, right? So let's go that our first node is at linked list start pointer. That is where our first node is. Now while true, what do we need to do? Node dot data, and yeah, that's all we need to print. We don't need to print anything else. And then where will we go? Our node will become updated and we will basically move to node dot next node. What is happening over here, guys? So if I were to show you as a visual, So currently this is my node, all right? I am treating this entire thing as my node, and this is at index equals to 0. Now from here I need to go to index equals to 1. So what I do is I basically replace the value in the variable, which is current node or just the node, with this value. Alright, so I think the more appropriate naming is gonna be stating current node. Currently I start at my start pointer and then I update my current. Alright, my current node becomes current node dot next. Alright, and how long will this continue? If my okay, we need to break earlier. I think. If current node dot next node equals to -1, we can essentially break. All right. So now, if we were to call this output node with linked list and with start pointer. Okay. Now let's try to run this. Hopefully this works. Oh, what happened? Name start pointer is not defined. Oh, we did not define it. Sorry. So we need to define the two values of start pointer, and start pointer is gonna be 0, and what was the other one? The other one was empty list. So we'll write that as well. Empty list is gonna be 5. Well, we will use empty list eventually. So I just initialize the variables. Now we can go to current file. Node is not different. Oh, current node hobe. This is gonna be current node. Int object has no attribute data. What just happened? Current node. Oh, sorry. So one thing, guys, understand this. This value is 1, right? Which is current node dot next node. But then this value is basically the index position, right? This is what it's showing. I need to go to this index position. So current node will basically become what's the name of my linked list? Current node dot next node. Okay, 1252656 7. I hope this matches with our 125. Wait, did we get it right? 152656. 152656. Yeah, it makes perfect sense. We basically have the linked list up to the point which is filled, because these are blank spaces, right? We don't really need to output the blank spaces yet. Now, understand something, guys. Will I circle back to it or should I explain it now? Just give me a second. Okay, so this part is where a lot of you guys will get tripped up. So see what's happening. Initially, I started off with current node as linked this start pointer. What is the value of start pointer? 0. Then what did we do? We said we'll print the current node dot data. Makes perfect sense. Now, if my current node dot next node is equals to -1, where does it happen? It happens at index equals to 3. So then we will break because we don't need to go any further. -1, basically the index should not exist. In Python, the -1 index exists in a Python list because we can use negative indexing. But in real life or in most programming languages, negative indexing means it's an error. Indexing starts at 0 and it goes on in positive values. Alright? So here it's breaking, and here what's happening over here? Current node equals to linked list current node dot next node. What is the value when I am at start node equals to 0? I mean start node equals to 0. The value of my current node dot next node is 1. Alright. Then when I say linked list 1, it is basically referring to this entire block. So now I have made the switch and then I can just move on and on the way we simulated this entire simulation. Alright. So the exact way that we generated this image or this drawing is what we're supposed to code over here. That output nodes until you reach the point where it basically reaches the last node. Okay, so we have done this part. We can move on. I think this part has also been done. Okay, the function add node. Add node takes a linked list and pointers as parameters, then takes an input data to be added to the end of the linked list. So how do we do that? We do that by doing this thing, right? We basically need to know which position we need to add the data and then link it up. So first, let's do this. Def add node. We're going to take in all of this as parameter. Linked list. Then we have start pointer and we have empty list. Alright, so first of all, it can be possible. I think it's also mentioned in the question. The function adds the node in the next available space, updates the pointer, and returns true. So we need to return something, true or false. If there are no empty nodes, it returns false. So first we need to determine how can we say whether there are any more empty nodes or not. So currently, this is the variable. Empty list is the variable which is showing where is my current empty list, or like where is my first vacant space in my entire list. So currently the value of empty list is 5. So when I add a value, so I suppose I add a value 100, the value of empty list will get adjusted to what? It will get adjusted to 6. So suppose I add another value which is 90. After that, what will happen to empty list? The value will get adjusted to 8. Why 8? Because 6 was pointing to 8. Alright. Then suppose we add another value and this is 70. Then the empty list value will get updated to 9. Then we add another value of suppose 101. After that, what will happen to the value of empty list? It will basically go outside the range, right? And eventually it will either become -1 or it will basically be not within 0 to 9. So this is what gives us the condition of whether we need to output false, I mean return false. So if empty list is greater than equals to 9, or sorry, not equals to 9, greater than 9, or empty list is less than 0, then we can easily say that this is return false. Alright, now for the return true part, what do we have to do? Oh, I forgot to take a data as an input. Take a data. Let's get back to our question. What does it say? Takes input data to be added to the end of the linked list. Alright, so first of all, we need to figure out where is the end of the linked list. How can we do that? We can exactly use this loop, right? We can just use this loop. We do not need to print, but it's going to help us debug. And we continue doing this. Eventually, current node will have the value of this node. Alright, I will, when I reach 7, basically index equals to 3, I will get a dot next equals to -1. So I stop over here. After stopping over here, what do I have to do? I need to make this connection, right? Let me erase this thing so that it's a bit more clearer. So now I basically need to make this connection, guys. I need to, this is currently pointing to nothing, but instead of pointing to nothing, I have to make sure this points to the index equals to 5. Where will I get index equals to 5? Inside my empty list variable. Alright, so the first change that's happening is current node dot next node is going to be empty list. So that is point number one. Point number two, my empty list also needs to get updated, right? So to do that, what will it get updated to? It will get updated to basically in this case 6. But how do we get 6? 6 is basically the dot next of the index which I have inside empty list. What do I mean by that? So where do I get 6? 6 is basically currently this is my empty list variable. My empty list has the value 5. Now how can I get 6? The value 6 is basically um, linked list. We have empty list. All right, empty list means this entire thing, and this positions next node, which is this property. All right, so we're basically going to write that down, that empty list is going to be, wait, what did I just write? Empty list is going to be linked list empty list dot next node. All right, and then we just return the new value of empty list. Return empty list. Why do we need to return empty list, guys? Because oh, why did I do it in the while loop? This will be outside the while loop. Like this will be after I have reached my last element. Okay, so why do I need to return the value of empty list, guys? So that the value gets updated in my main program. So once again, if you don't understand the concept of global variable, local variable, and how the values don't really get passed around, then you will make mistakes like this, and then you will not be able to add up. All right. Oh, one step I missed. I did not add the data. So what? How can we do that? Very straightforward. I'm just gonna do linked list empty list dot. Wait, is the word data already used? Okay, let's just use value over here. We'll leave this value so that there's no naming confusion. Dot data equals to value. All right. So now let's try to. I think there's a testing code right after this. Output an appropriate message based on the results. Oh, I'm supposed to output true, I think. Return true, right? The function adds the node to the next available space, updates the pointers, and returns true. Okay, so we need to do this as well as this. We need to return true as well as empty list. Now, understand this, guys. If we do not return empty list, the value will not get updated. So even though the question says you just return true, for the purpose of testing that whether I am actually able to add node properly, we need to do this. Otherwise, the value will not get passed outside the scope of my local variable, of my function. All right, because it behaves like a local variable. All right. Edit the main program, call add node, output an appropriate message depending on the result returned from add node. Call output nodes twice, once before calling add node and once after calling add node. So these are pretty straightforward stuff, guys. Let me see if there's anything difficult in this problem. Okay, there isn't. So we can do it, I guess. It won't take long. We need to call add node and then output appropriate message depending on the result returned from add node. Okay. Okay, let's just stick to the instructions in the question. Return true, return false. Because, okay, the reason why I'm making this change, guys, it's because the value of empty list. Now, I should need to update it. I don't think it will get manually updated. Okay, let's try with this first. Otherwise, we know what to do or where we might have made a mistake. Firstly, it says call add node. Okay, let's call output nodes first. We already did once. Output node. Okay, and then what do we do? Call once before calling add node and once after calling add node. Okay, then we are supposed to call add node. Just simply add node. Add node we use linked list, start pointer. What was the order? So maintain the order, guys. If you mess up the order, that's gonna be a problem as well. Empty list, and let's add a value like 45. All right. So if we do this, we can also do something to differentiate properly. You don't need to do this in your actual answer, guys. I'm doing this for our betterment. Current file. Okay, it works. So 1526 56 745, and then it works. All right. So I missed one minor step. What minor step did I miss? Let me tell you guys. So the way I understood that I missed a step was, see, there was no trailing zeros after 7, but here after 45 I get 3 trailing zeros. So I don't want the 3 trailing zeros, right? So what I have to do is I need to change the dot next value over here to -1 as well. All right, I need to change the dot next value at 5 to -1. Basically currently this is at 6, but now this will become -1. Now the question is, how will I connect to 6 then? It's because empty list has been set to 6 right now. So those changes will be affected eventually. So what we need to do is, mm, after everything has been done, like right before we change empty list, we need to do this. Current node dot next node is empty list. Great. Then linked list, empty list dot data is the value. Correct. Mm, let's save it somewhere, or we can just do this now. Linked list, empty list dot data. Okay, I know what to do. We'll just use a temporary variable in temp. What are we gonna do? We're gonna store this value. Why are we storing this value in temp? Because this value will be replaced by temp. Because right now I'm gonna turn this value to -1. Alright, now this should work. Current file. Yeah, you see, because we made those changes, now it was 656.7, now it's 656.745, and we don't get the trailing zero. So you need to make this slight change. Then the reason why we used a temporary variable was when we're overwriting a value with -1, it would eventually affect linked list, the value of new value of empty list as well. So we don't want that. Alright, so yeah, this was a pretty easy question, pretty straightforward. When you are actually well practiced and sitting for this exam in an exam setting, it won't really take you long. Alright, and then you can test your program with 5. Okay, so one let me clear one thing. Remember when I was trying to do this initially, that I was trying to do empty list comma true, and I wanted to get the value back because I knew. And if you guys, oh, I made a spelling mistake. Acha, the spelling mistake, not a spelling mistake. Wait, what? Okay, so the point I'm trying to make over here is, guys, if you see my solution of October number 21, which was it? October number 21, variant 41, question number 3. You will see that doing something like this sometimes becomes very important when we are trying to call a function repeatedly. Over here, we are calling add node only once. Hence, we can only use the value of true and false, and it does not really affect us. Alright? And we skip this part, that output an appropriate method. How can you do that thing? You can just do this. You can return status. If status equals to true, you can print new node added. Else, you can print no space. Right? And if you do that in the current file. Oh, where did we make the mistake? How did this happen though? Linked list. Ah, name error. But yeah, you see, now you get an appropriate message that new node added. Alright, so yeah, that's pretty much it, guys. I hope you guys understood. We'll be continuing with the next question in another video. Until then, take care and Allah Hafiz.